Alright, here's a little help with your homework packet for Integrated 3. I'm going to do number 7. It's one of the graphing ones. It wants you to graph, number 7 wants you to graph this one. I can look at that and see that it's a parabola because it's got the x squared in it, so I know it's going to be a U shape. There's plenty of ways to graph that. You could just go on Desmos and see what the graph looks like, and then you could just write the graph down, or you could factor it. I'm sure there's a lot of techniques you could do. I'm just going to use a very simple technique of just plotting some points. You can use this with any type of graph. So I picked some points that I think are very easy to do math with in my mind, and then I'm going to plug this into the function. So in other words, for x, I'm going to plug in -2, and I'm going to calculate what I get. So -2 squared is 4 minus 2 times -2. Well, that's going to be a positive, so it's going to be 4 plus 4 is 8 minus 3. I think that gives me a 5. Okay, so I'm just plugging -2 in where the x is. So now I'm going to plug in -1. I'll try to do it in my mind. -1 squared is 1, and then these two, when I multiply -2 times -1, that gives me positive 2. So what did I have? 1 plus 2, that's 3, minus 3 is 0. Plug in 0, that'll be 0, that'll be 0. Got -3, plug in 1, 1 squared is 1, minus 2 is -1, minus 3, I don't know, I think I got -4. Let's check that. 1 minus 2, that's -1. Yeah, I think that's right. And then 2, when I plug the 2 in, okay, so 2 squared is 4, but then this is going to be -4 because it's -2 times 2. So 4 minus 4 is 0, minus 3. So I don't know. I got this so far. So if I calculated those right, if I did the right kind of arithmetic on those, these are ordered pairs that I can put on a graph. So I'll just make a quick sketch of it, and I might have to add some different points to it, but from what I have here, I have -2 and 5. Now, if I had graph paper, that would be better than what I'm doing here. -1 and 0. That's right here. 0 and -3. 1 and -4. So it's still going down. 2 and -3. Oh, but it's coming back up again because 2, -3, that's right here. Okay, earlier I said I knew that this is a U shape, so I'm going to start connecting them. I already knew it was a U shape because of the squared term here. Since it comes back up and it has symmetry right here, I know that it's just going to come back up like this. I'm supposed to describe my graph completely, so I do need this intercept. So I guess I'll just plug in another number. Let's try 3, and maybe we'll get lucky, and maybe 3 will give us the intercept. So 3 squared is 9. 2 times 3 is 6. 9 minus 6. 3 minus 3 is 0. Okay, so here's our intercepts right here. The x-intercepts happen when y is 0. So this is going to be 1, 2, 3, 0. So now I'm going to say some things about my graph. What am I going to say? Well, in my packet it says, what's the shape? So I'm going to say U-shaped. And lines of symmetry, I'll say symmetry about, it's right here, this is the middle, so that's where the symmetry happens. So what would this dotted line be called? A horizontal line. This would be called, this is x, and this is y. This would be called x equals 1. There's some symmetry right there. There's a line of symmetry. I guess I can write line up. And it opens upward. I'm just kind of answering the questions that this is how you can describe a graph fully. I'm going to say no asymptotes. If you don't know what an asymptote is, if you read, it shows right there in your packet what an asymptote is. What else do I want to say about it? Is it increasing or decreasing? Well, it's like decreasing over here, then it's increasing, so I'm not going to say anything about that. I'm going to say the x-intercepts, and I'm just going to say what they are, 3, 0, and -1, 0. Does it have a y-intercept? Yeah. Y-intercept, I hope your homework's a little bit nicer and neater than this. The y-intercept is at, so is that 0, -3? Gosh, it's a long problem. Domain and range. So domain is all the x values that the graph can cover, and so I look at the x-axis, I see the graph extends off to the left and the right, so I'm going to say the domain is all real numbers because I can plug any x number in there and get a y value out. And then what's the range? The range is all the y values. So I see that the graph goes up, up, up as far as the y-axis goes, but it doesn't go down infinitely. It has a bottom. So the bottom of it is, so I'm going to say x has to be greater than or equal to -4. This really looks messy. So maybe I'll put some little bullets. Maybe you'll figure a nicer way to organize your data here. Endpoints, there's no endpoints. I'll say there's a minimum at right here, this vertex. So this would be 1, -4. And is it continuous, discrete, or neither? So I'm going to say that it's continuous because it doesn't have any breaks. Is it a function? Yes, it passes the vertical line test, and I'm going to say it's a function. Is that all that I was asked to do? That's really long. I don't know what kind of teacher would give you such a long problem. Be sure to label each graph carefully so all the key points are identified. Graphing completely described. So I think we're done. These are my key points. They're my intercepts. Because I have these little tick marks, I think I'd be okay with that if you did it like that too at home. Okay, we'll talk about these in class.